Okay, good morning, good afternoon, and good evening. This is the Cisco Cybersecurity Operations Associate Training. I'm Victor, and I'm going to be your call for this training. This is the 28th module series for cybersecurity. First, mate, I want to start up in Tier 1 SOC to be a SOC 1 SOC analyst. A SOC analyst is somebody that works in a cybersecurity team or a security operations center, and you have level 1, level 2, level 3, and of course a SOC manager. So level 1 is that entry level where you intend to do some research, do basic penetration testing, get to raise tickets, attend to tickets, check out for vulnerabilities, check out for um, threats, and do basic cybersecurity research. So this course is very handy because it walks you through both network, both web, and we are in module 3, or rather module 13, and we're talking about attackers and their tools. So what are the tools that attackers are going to use? We should be able to use these tools. We should be able to understand these tools so that we can put ourselves in the stead of a hacker, get to see the kind of information they have access to. And of course, we're going to see how we can patch this up or pass this on to either network engineers, senior network engineers, or senior developers to be able to correct most of these things. So we want to explain how network threats are evolving or have evolved over time, and how these different attack tools are used by threat actors. The bunch of tools we have here, quite much. Who is attacking our network? Who is attacking our website? Who is attacking our IT infrastructure? So there are a few things you need to understand, that we have threats, assets, and vulnerabilities. So you need to understand some of these terms and how they differ. A threat is that potential danger to an asset, such as data or network itself or a web. That potential, that's why threat intelligence is very important. Vulnerability, talk about weakness in design, in configuration. If I have a router and I don't put in the correct username and password, I leave it at default, that's a vulnerability. If I have a website and I use default themes and templates and compromised themes, what am I doing? I am making the application vulnerable. And it's a vulnerability assessment that is not going to result to a threat. From a threat, we cannot have an attack. And it's a vulnerability that is going to be exploited. Attack surface, what are the different means through which data can be gotten? Exploit, how will that be compromised? How will the vulnerability we have be compromised? And of course, risks, what's the likelihood that we're going to have an attack? Now, 4 ways to manage your risks. If you have a risk, if you have a likelihood that a particular threat will be exploited, what do you need to do? You accept the risks, or you avoid the risks, or you reduce the risks, or you transfer the risks. What are the kind of things that you can do that amounts to you transferring the risks? Third-party insurance, right? Outsourcing that particular service to a company and say you're going to do XYZ for us with respect to so kind of vulnerability or a particular security uh, issues that we might have or that we have. You're going to take care of our network security, you're going to take care of our web security, or you're going to take care of our cloud security. What you are doing is that you are transferring, of course, all of the consequences that arise as a result of your engagement with us, right? If anything fails, you are liable for it. And of course, most of those contracts are going to have some force majeures. They're going to have some give and takes and some boundaries with respect to what's possible and what's not possible. So that way you are transferring your risks. Whereas for risk reduction, most of the times there is uh, always something left in terms of your risks, even after you have patched up all of the vulnerabilities. You call that residual risks. So, residual risks is as a result of you exploring the risk reduction management strategy. So, by you have vulnerability A, B, C, D. So, you patch A, you patch B, you patch C, you patch some part of D. But there are some critical things you have in D that you cannot completely patch. Take, for instance, for an access control system, you might put all of the IT gadget, access control, biometrics, fingerprint, all of the things you can have. Password, people need to enter a password to be able to access to your room and whatever. But there are some things that you cannot completely rule out. You cannot rule out social engineering. You cannot rule out tailgating. But the point is that you have actually reduced that risk to a barest minimum. Or for instance, you have a building and you fenced it and you've gated it, but doesn't mean that somebody cannot pour a chemical on the wall of that building and still have access to the building from behind. That risk is a residual risk. So you only reduce your risk because you cannot completely take care of 100% of your risks. That's why we say there's no 100% secure system anywhere in the world. There's always an outer, there's always a likelihood, there's always a little part of that risk left. And of course, avoidance and acceptance. So, common vulnerability terms that you're going to be hearing in terms of cybersecurity is countermeasure, impact. Countermeasures, what do we do? I do tell my students that as a cybersecurity expert, there are few things you want to be knowing and understanding. You should understand that um, knowledge plays 33% of your arsenal. Tools, techniques, tricks, tips plays 33% of your arsenal. You want to fight cybercrime? So you have 33% your knowledge, your understanding of complete theory, concept. So you have definitions, concepts, technologies, implementation, right? You have this as what? 33%. So your knowledge plays a great role in making you succeed in cybersecurity. And the last one is countermeasures, penetration, vulnerability assessment, penetration testing. Of course, I could add security audit here. Here, this is the last 33%. So how many percent do we have left? We have 1%. So that residual risks is the remaining what? 1%. You can see that the risks that you have left at the end of the day is called your what? Residual risks. It then means that everything here will give me a 100% strategy towards cybersecurity, towards cybersecurity. So don't think that because this tool, this module is about attackers and their tools, that you just need to go and learn all to know. You just need to learn how to use all of the tools and you are done. No, you still need to know which tool to use, when to use the tool, how to use the tool, and some tools are going to be complementary to other tools. That's why I tell students that cybersecurity is a journey, right? They need to be able to know countermeasures for most types of attack. That's why research and development, which is here, your knowledge base, right? Your knowledge base with respect to what you know is very, very important. Because if you don't know much, how would you know what countermeasure you're going to implement? If you don't know much, how do you know which tool you are going to implement? Right? Then you should be able to do security audits. So security audit is you checking if systems are following standards. Most of us will have auditors at work. So are you following standards, compliance? And it all starts from an information security policy document, which encompasses a password policy, a network policy, a website policy, depending on the size of the organization. So the next thing you want to be able to do in terms of your strategy is vulnerability assessment. You should be checking out for threats. You should be checking out for loopholes. You should be checking out for susceptibility for attack from time to time. You log them, you pen them down, and you should be performing penetration testing. You should be trying to simulate these attacks and see if you're going to be successful. Then, of course, you now know what to patch up. Okay, okay, so that's my approach when it comes to making people understand what a cybersecurity strategy is all about. So it involves quite a lot. So your knowledge base is very critical, your tools, techniques, tricks. Somebody can know just a simple trick or a technique and he doesn't need a tool. Somebody's knowledge base can help solve a problem. Somebody understanding of basic countermeasures can solve a problem. Somebody's understanding of penetration testing can help solve a problem. So you have to build competence in these areas. Okay, threat versus threat actor. So a hacker is someone that's going to cause system malfunction. You have different types: the white, gray, and black. So these are basics. Script kiddies, vulnerability broker, hacktivists, cyber criminals, state-sponsored hackers. Cyber criminals. The difference between an ethical hacker and a black hat hacker is not much. The primary difference is what's the purpose. So same tools, same techniques, same everything. The difference is that for ethical hacker, you have permission to do testing, to hack. Then your purpose is so that you can protect. But the black hat hacker, it doesn't have permission, and the purpose is always to cause system malfunction. But every other thing is all same. Okay, so there are things you call indicators of compromise. So you say indicators of compromise when you see features, when you see behaviors, when you see stuff within your IT infrastructure that looks like you have an attack. Things like your system being slow, things like files turning to new different different file types, things like your system always crashing, things like you being on the website, being redirected to somewhere else. Those are, or you check your hash value. In our digital forensic course, we did hash value. That is integrity. You do integrity check and you see that there's discrepancies. So these things are indicators of compromise. Indicators of an attack focus more on the motivation and strategies behind an attack. And we should understand that you cannot have an attack without a vulnerability, a motive, and a method. I call this my hack equation. So without, if it even starts with a motive, somebody will have to say, I need this, I want to get this, I want to be able to do this. Then he now looks out for vulnerability. If a hacker checks out for vulnerability within your IT infrastructure and they don't see any, there is, and they don't see a vulnerability, there's no how you're going to have an attack. So that's why the primary goal, why you have cybersecurity experts, is just to go look out for vulnerabilities. That's your daily job. Look out for vulnerabilities. Look out for vulnerabilities in the network. Scan the network, see what is vulnerable, see what the attacker is seeing, and you patch. Check across your website, your forms, your web pages, your server, your email, in and out. For website, for instance, you're going to be using the OAPS, right? Open Web Application Security Project. There's a 2021 version now, right? So you want to use that and map out that to your web applications and your softwares, and make sure that you go through step by step and you check for vulnerabilities. Because what the attacker is going to do is go to check for vulnerability. If he sees any, of course, it becomes open knowledge. He's going to look out for how am I going to hack this vulnerability. So hackers are very intelligent, like we said here, right? Clever programmers. So you cannot say you want to be a security expert, cybersecurity expert, and you're not interested in programming. You should and must. If you want to be a hacker, you should also be a network professional. That's why you see 4 of the modules of this CyberOps training talks about networks. You want to be able to know how to run basic programs. Like I said, being able to use the 3 major operating systems, Windows, Linux, and Mac. Be a power users of these operating systems, right? So before you can have an attack, you must have a vulnerability first. Of course, a motive first. I can even invert this, or rather substitute this to be a motive first, a vulnerability, then a method. Once there is no method to hack your system, the hacker is just going to find his way, get to the next attacker, right? Because for every vulnerability you have, right, it's an open book knowledge on how to hack it. So you don't want to be doing a blind type of hack. You want to be doing an informed kind of hack. So, but the only way you can do an informed type of hack is if you know what vulnerability that you have, then you can research on that particular vulnerability, how to hack it. And of course, in hours, at most a day or two, you will see step on how to break through that particular vulnerability. Now, how do we share intelligence, right? So several governments are now promoting cybersecurity. So you have several of them: CISA, ISA, NISA, NCSA, and the rest. So because government needs their infrastructure, their networks, because government is one of the biggest spenders when it comes to IT government, right? Because they have a lot at stake. Yes, private sector spends a lot, but government is also a big player because healthcare data is in their domain. What's that kind of data? Most banking infrastructure, no matter though private sector plays a role, they still have a backend to most of this data. And that's why promoting cybersecurity will help them to be better secured. And just through threat sharing, if we can know what is happening in A, B is able to learn from that and implement countermeasures. There are several tools across the years, right? Tools within Linux, within Windows, and there are several of them. So we'll list some of them and understand how they work. Okay, so we're going to look at threat actor tools. So what are those tools that hackers are going to use to try to break through systems? So some of these tools, you call them network penetration testing tools. So they're in categories. So you have password crackers, wireless hacking tools, network scanning and hacking tools, packet crafting tools. When you say packet crafting, don't forget, I think that should be in module 2 or module 3. We talked about ICMP, that is Internet Control Messaging Protocol. So for every packet of data that move across the OSI model on your network, uh, devices are going to interpret them. So, but what about if we create our own packets and deceive devices like these packets are coming from a particular system? So that's the kind of thing that this HPing and SCAP is going to be doing. HPing is on Kali Linux operating system. Then you have packet sniffer. So what do they do? Those packets, how do we sniff through the packets and be able to catch up information that has been sent across our network? Especially for protocols that are not secure protocols. For instance, FTP, TFTP, that is file transfer protocol, trivial transfer protocol, SMTP, simple message transfer protocol, which other one again? Plain text protocols majorly. We're able to be captured by either TCP dump or Wireshark. Wireshark is open source. TCP dump is also open source. Wireshark is like the top, like the first guy uh, with respect to tools for packet sniffing. And of course, you have rootkit detectors. So you know rootkit that gets its name from the kernel of operating system. So those malwares are, of course, we say malware is the umbrella word for everything that causes system malfunction. So all of the Trojans, spyware, hardware, all of those guys, anyone that is going to infect the system kernel, the system root, those are the kind of guys that are going to make your system not boot to desktop. Those are the kind of guys that are going to eat up the operating system files. So you call them rootkit malwares. So how can you detect that? So file integrity is very critical. Like when we did the digital forensic trainings, we talked about integrity check, checksum tech. All you are trying to do is that is there any tamper of the files that we have in our operating system or in our files or in the directory? So what are the kind of tools that we can use to detect that? You have AID and of course Netflixer and so many others. Fuzzers to search for vulnerabilities. So fuzzers are like script codes that you can inject into a particular application. It can be a website, it can be whatever, for you to be able to detect system vulnerabilities. The categories continue, and you also have forensic tools. You have slot kits, you have Helix, you have Autopsy, you have FTK Imager, and several others that we used during our digital forensic training. Then, of course, you have debugger, hacking operating system, encryption tools, vulnerability exploration tools, and so many others. For vulnerability scanners, this is very important. What do you call BYOD? So BYOD is bring your own device. So many companies are going to have a BYOD policy. So depending on what their BYOD policy is, bring your own device. You should know that if an organization tells people, associate consultants, interns, full-time staff, freelancers to bring in their own device, that is an inroad to vulnerability. So how do we use tools and scan most of those devices, whether they are VMwares, whether they are BYOD devices, whether they are client devices, whether they are server devices. So you can use NIPA, Sukuri, Nexus, Bobsuit, Nmap. All of these guys are vulnerability scanners. Now you have several categories of attack. So it can be an eavesdropping attack. So don't forget, we have what we call social engineering. And social engineering is one of the, will I say, 10 methodology for reconnaissance and footprinting, of course, which is the first layer of any system hack. So we say before a system is hacked, it goes through 5 stages. So the first stage is reconnaissance and footprinting. The second stage is scanning. The third stage is gaining access. The fourth stage is maintaining access. The fifth stage is clearing tracks. So the first stage, which is reconnaissance and footprinting, we are saying that we have about 10 methodologies, 10 methods to doing footprinting and reconnaissance. Who is fingerprinting? Email footprinting and reconnaissance, social engineering footprinting and reconnaissance, search engine footprinting, and several others. So in social engineering, we have several types of social engineering, right? So you have eavesdropping, shoulder surfing, dumpster diving, and tailgating, phishing. All of these are different types of um, so eavesdropping is a part of a social engineering technique. So one way you can implement that on a network is through snooping or sniffing. Of course, you have data modification attack, and of course you have IP spoofing attacks. So these are categories of attack. Then you have password-based attack, denial of service, man-in-the-middle attack, compromised key attack, sniffer attack. So that's all for the attackers and their tools. If you explore these tools, you have average of 2 per category. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right? So if you go by this 13 or make it 12 times it by 3, you have roughly about 36. So knowing 30 tools in all of those categories is a big plus for you. You could qualify yourself to become a tier 1 cybersecurity operations analyst. Okay, so that's the summary of the attackers and their tools. So what did we learn? We learned about risks, exploits, attack surface, vulnerability threats, risk management. How do we mitigate, or how do we manage risks? So you could either accept it, you avoid it, reduce it, or you transfer the risks. A classical way to transfer risks is insurance outsourcing to a third party. Then we looked at several types of hackers, gray, black, and threat intelligence and sharing that intelligence is very important if we are going to, as a global village, mitigate most of these cybersecurity threats. Okay, I'm going to see you in module 14. Thank you very much. Please don't forget to check up your Cisco learning management system and read up, take your notes. If you have questions, please check up the mentorship group and ask your questions, and I'm very much happy to reply.